in this uncertain times. Thank you. So now that we're getting into this uncertain times, how do we scope projects while balancing the expectations from our client or sponsors, the student learning, the academic timelines, the limited resources for prototyping we might have? So how do we handle all of that and scope our projects appropriately? So we have our panelists here, Dean, Steve, and Chris. They, in a little bit, we'll introduce them as well. But what they're going to bring to us and get the discussion started on is potentially setting some expectations with our clients ahead of time when we get started. Then we also want to talk about some strategies to have some in-course planning or activities that will help the teams remain agile. And finally, how to help the students finish strong with their projects at the end. The plan of this session is that the panelists will introduce themselves and then they will pick their favorite questions to address. We already asked for some questions from the audience, and thank you so much for those who submitted it. So they will be answering some of those questions, and then we want to move on to live questions. And finally, toward the end of the session, we want to save some time so we can direct some of these open unanswered questions back to the attendees. The reason being that we want to gather the collective thoughts from everyone. So if you have some interesting comments, please share back on those questions that are not necessarily answered. And that's how we'll go ahead with this session. So now I'm moving forward with having the panelists introduce each other. So the first one to start is, I believe, Steve.
Yeah, so yeah, it's my pleasure to introduce Dr. Chris Helton. She's a teaching professor at Mechanical and Industrial Engineering Department at Northeastern University, director of their Industrial Engineering Capstone program. And she teaches human machine systems, simulation modeling and analysis, and facilities planning, as well as coordinates and advises in Capstone. Chris has advised a variety of teams, including international projects, healthcare-focused projects, projects involving community partners, and product design. And at Northeastern this summer, she helped coordinate their first offering of an all-online capstone. And while her doctorate was in human machine systems engineering, Chris also minored in cognitive psychology. And she's worked in industry and has done quite a lot of consulting in engineering design and in forensic cases. Chris has a passion for empathetic design, as well as any process that makes a system more usable and efficient for all. She loves getting to work with brilliant students, clients, and colleagues in Capstone and beyond.
Thanks, Steve. So next up is Dean. And I apologize for not mentioning that we do have a live notes document. So we'll post the link again. It's already posted. So please go to the live notes and documents, and all the ground rules agendas are in there. If you have questions, you can either add it to the chat window, or you can go to the live notes and add your questions and comments there. So just so you know that that's the same format we are using. So Dean? Dean, you're muted.
Oops, sorry. I did the wrong. Okay. I have the privilege of introducing Steve Byers. He's a professor of mechanical engineering at the University of Idaho. And he began teaching Capstone in 1996. He's played an active role in shaping the current college-wide interdisciplinary program. Each year, this program annually involves more than 30 externally sponsored projects. These are 2-semester projects that engage more than 130 students, 8 to 10 faculty members and 6 graduate students, as well as 3 technical staff.
Go, 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 it's fine.
He has a long-standing interest in the design pedagogy and in design assessment, and he has published several dozen articles in this area.
Thanks, Dean. So next up is Chris introducing Dean. And before we do that, Beth, if you want to mute and unmute, that would be great.
Ready?
Yep, Chris.
Thank you. Dean Knutson is an associate professor in the computer science department at North Dakota State University. After 40 years in industry at Bell Labs, ITT Advanced Technology Center, Honeywell Systems and Research Center, Northrop Grumman, and Microsoft, he began teaching the computer science capstone class at NDSU. This is a one-semester class with 85 to 90 students who work on 20 to 22 industry-sponsored software development projects each year. Dean has a strong interest in international capstone project exchanges, and his teams always take on some international projects every year working remotely. And now I'm going to hand it back over for some polling.
So Beth, you're up with the polls.
Great. So before we started, we thought we'd get a feel for who's attending this session so that we can, maybe adapt some of the responses depending on what sorts of projects we're doing. So the first poll we're asking you to respond to is, what discipline or disciplines does your program include? And you should be able to check any that apply. All right, great. Wow, this is awesome class participation. If only it worked like this all the time. So we're gonna close this one out. And just so you can see, we've got pretty heavy representation from mechanical and aeronautical, computer and electrical, and folks from all over the rest of their colleges. And our next poll is, what's the format of your capstone? So this is both in terms of the duration and whether you're looking at, in terms of your best guess, online, in person, or some other combination. All right, give you another couple of seconds and we'll shut this one off. Okay. And so it looks like the vast majority of folks here are doing a combination of online and in person, and you have multiple terms, whether it's 2 semesters, 2 quarters, or in some cases even more. I think we've got a few universities who do 3 terms or a full year. All right, we'll turn it back over to the panelists to answer some preliminary questions. Strada, you are muted.
Sorry, Steve, you're up next for the questions you picked from the audience.
Okay, I'll just do 1 or 2. We probably just want to rotate around a little bit, but
Sure thing.
I mean, there are a number of questions, especially in our current climate, that deal with managing uncertainty. But as we all know, teaching capstone design is all about managing uncertainty. In fact, I think that's why a lot of us enjoy teaching capstone design, because it's a very authentic, real-world problem-solving experience. That said, remember, you don't have to be like Sisyphus with the rock just on your shoulders. So I encourage you to think about the wider community that's involved in scoping projects. It's not all about just the company project. You want to engage your corporate sponsors, telling them about your course design and your outcomes. And there is some amount of negotiation in coming up with a course that meets both the academic and the client requirements. The client requirements are not to be taken lightly, because we do need a product that's client accepted. As we think about the broader community, though, there's lots of opportunities on campus with other faculty and graduate students to engage them in project scoping. There's the wider community that you see represented here at the Capstone conference, and a lot of people have great archives of past projects that are nice to mine, especially if you're a new Capstone instructor. And I also would encourage you to look at some of the special issues of the International Journal of Engineering Education that have come out of some of the previous Capstone conferences. Some of my notes from today come from a paper that I did with my colleague at Washington State University on managing project scope for successful engineering projects. And that was in the 2017 International Journal of Engineering Education. There's lots of resources there. There's several people in the audience that have done some excellent textbooks and case studies, not only just on teaching design, but also facilitating design. So reach out to your larger community, embrace the uncertainty. We'll talk about managing different elements of uncertainty as we move through the session. If you want to rotate, Sharada, I mean, it might be good just each of us take a question or two.
Dean?
All right, well, I'll kind of bundle a couple in a sense where we're really talking about scoping, but I think there's a lot of interest in how do you manage dynamic scoping as things might be changing throughout the semester. And I think I'll talk about some of the processes that can be used to make that a lot easier. Now I'm in computer science, but the Agile process is something that can be used by anybody, but we use an Agile process, and so with that, we have sprints, and sprints are about 3 to 4 weeks long in our course. And so at the beginning of each sprint, the students update a project specification document, and they basically say, here's what we're going to be doing for this next sprint. They get agreement with the mentor. And by the way, we have mentors, not faculty advisors. And so all of the sponsors provide a technical mentor that meet virtually with the teams every week. So the team is constantly working with the mentors. At the beginning of each sprint, though, they say what they're going to accomplish. And that's about a 3 to 4 week interval. At the end of each sprint, there is supposed to be something delivered that's of value to the customer. So as you go through these sprints, you're building up something of value. So anytime along the way, if you have to stop, you have already produced something of value. And the documents, the code, everything is put into configuration management, so it's always available. It's a live set of documents and code that are visible by the mentors, by the faculty, by the students. And so as you're progressing, you could actually cut things off at any point, and the customer is able to just pick up what has been done at that point and continue.
Thanks.
So
Awesome,
that's a quick version of how that would go.
Okay. Chris, you're up.
Thank you. Like a good industrial engineer, I've batched my answers, so I'll probably talk a little bit longer, and then Dean and Steve can rotate. I'll be covering some about scoping and more about preparing the students and their mindset. And then later we'll address the final deliverable. So as we all recognize, there's many facets to scoping projects. Especially in these changing times, we've addressed the client side of things with Dean, as well as the Agile approach. We'll need to consider the students as well and how you manage that. Also, us as faculty and ABET or accreditation elements in our respective programs as is fitting. So the student's sense of disequilibrium when the unexpected happen needs to be anticipated by us as capstone leaders. So we tell them it's going to happen. In some ways, it's a race to be the first to encounter the unexpected. So what are some strategies? In my segment here, what I'm going to do is I'm going to directly or indirectly be addressing some of the questions by many of you. In particular, Tom Henderson at UT Dallas, you asked about rubrics. Robert Nagel at JMU, you talked about balancing course learning and scoping. I'll touch upon the questions about a little bit about moving online by Monique Mocard at ACU and Chuck Bomer at ASU, although that's an entire session on its own. So I'm going to just start with mindset preparation at the beginning of the course. students tend to arrive with a folklore about how hard Capstone will be. And most resolve to avoid this hard, difficult time with planning and program management. This helps, but it doesn't prevent the eventuality of the various curveballs and setbacks they're going to encounter. So here are 5 quick ideas, and then maybe I'll hand it over. 5 quick ideas. Stories. We'll begin, and I want to acknowledge my co-coordinator, Hugh McManus, who has been attending the sessions. So we do some of this together, and some of this happened before he arrived to Northeastern. We describe accounts of various projects that have needed to be revised and were successful because of the agility of student teams. So we tell the stories. Alumni really help with that as well. Research. My excellent colleague from Northeastern, Bridget Smizer, and I conducted research on tolerance for ambiguity and success in Capstone. We published that paper at ASEE, and early in Capstone in IE, we conveyed to the students what we found, namely that the students with the highest tolerance for uncertainty and strong resilience in terms of attitude and ability to rescope had the most success. And this was regardless of how badly their project may have faltered initially. So I've delivered these findings to students in Capstone at the beginning and in conversations when they encounter setbacks. So there might be a link to that, there is. Activity is the third thing. In past years, in person anyway, I've tried an exercise whereby the students are given a task or a problem to solve, like the bridge one that you saw before. And on several occasions during the task, we change the rules, the resources, the requirements. So we see the difficulty they have when this happens, but the debrief is more about how it was handled than the final product. So this is a dry run for the bigger reality in Capstone. So there'll be more ideas in the teamwork session following this, but this activity relates to adjusting and rescoping. And Mark Anderson at RPI also asked about rescoping and bending projects. So this indirectly prepares the students for this probability. Earlier, Suhail Sekri had a Legos Connects activity for divergent and convergent thinking. And so this is where we are. So we've got stories, research, activity, and analogy, and I have one more and then I'll turn it over. Analogy, I'm working on my private pilot's license and I use my flight planning and flight path as an example of deviation from the ideal. On every flight, an airplane doesn't just get airborne and fly straight to its destination. It's involved a series of dozens, if not hundreds of adjustments. Some are due to corrections and others are simply just responding to outside elements like wind and weather and thermal. So by this analogy, the point is for the students, a successful journey is not flawless and not linear as we would expect. This idea of multiple corrections to get to your destination has resonated with the students, open conversations when projects appeared to be under duress. So then we talk about adjusting as not an admission of failure, it's just an iteration from a data point. And the 5th thing is advocacy. I've used a couple of previous Capstone flounders to engage students in an ideation session. Half the class in their teams were given a case in which the company who took on a Capstone team actually solved the problem by purchasing a piece of equipment from Pitney Bowes. True. Now what should the team do? So I have the Capstone teams decide in their teams and then report out. The other half was given the situation, also true, and the company dissolved at the end of Capstone 1. We do not treat these as disasters, just problems that good engineers tackle with creativity and initiative. So they reported out the ideas. All the students saw each other modeling resilience and a growth mindset. And any less productive approaches that might have come up really did not fit the culture that was created by the students. So that was mindset, and I'll stop there.
Thanks, Chris. Steve, would you like to pick another question and address that?
Yeah, so I guess this would sort of deal with sort of classification of projects and making sure that you don't get overextended on resources. I might just point people's attention to the scale that Benkin had put together for NASA many years ago on technology readiness. I mean, the scale is a 10-point scale. Sort of begins with a couple levels that are very research oriented, maybe trying to determine whether there's even technological or scientific principles that can be applied. Levels 2 and 3 sort of deal more with proof of concept prototypes, and then 5, 6, 7 over creating prototypes that run under specified conditions, all the way to legacy systems at the technology readiness level 10. So looking at the list, getting a sense of where the project is at the beginning. I mean, a lot of times your client has done some previous work on a project. My past experience is you do want to stay away from the low end that's more of a research project, not a design project. I think all of us want real prototypes that come out of capstone design. But potentially, you know, in working with your client, there might be advantages of pursuing something that's more of a proof of concept at that end, or something that's more exploring a device that's more advanced and doing more rigorous testing and refinement of design. And as I may have mentioned, that I wouldn't, as you move a project from beginning to end, I think it's unrealistic in Capstone to go more than about 2 levels in the technology readiness.
Thank you, Steve. Dean, I believe you had a comment or a question to address as well.
Yeah, I think the question kind of went away, but I think it was, how do you,
How about this, Dean? You were talking about some international projects. Would you like to talk about that?
well, I was going to bring up one just to be controversial. So there was a question that said, is a paper solution at the end acceptable? And I'm going to say almost always no. And I think the reason I want to say that is because in a previous session, there was the concept of peeling the onion, and you start with the core and then you add a little bit and add a little bit. And that works really well for teams that have various skill abilities too. But I think you want to be able to have that small nugget at the very beginning, that you don't have to go very far before you've developed something that has some value, even beyond just a paper thing. We have a very early prototype of something. And kind of going along with that, I think, is the flexibility that the teams take on when they have that feeling. We had a project last year that was working with drones, and drones fly over construction sites, they map them out, they do all kinds of things, but they always look down. Well, if you're flying around a construction site with a drone, you can run into a big crane because you're not looking sideways. So the project was to put sensors on a drone and send images down to the person flying it to show them to watch out for things. Well, partway through the semester, we hit the virus. The mentor said, nope, you're not going to get a drone. You can't do this. So the students were like, okay, we'll just build a little wooden box that doesn't fly around. We'll just carry it over our head and we'll walk around and we'll see if we can show that we were not going to run into things. So I think a lot of times you can work around some of these problems, but I think in the majority of times, I think the students get very creative and they can deliver something.
So
Thank you, Dean. Go ahead, Beth.
So we have another poll for you. One thing that has come up in a variety of different conversations is what sorts of deliverables are folks requiring of their capstone students? So building on what Dean said, are you delivering physical prototypes or full implementation of your project, something like a mock-up or a very low fidelity prototype, something that's only on paper or simulation, something else, or we don't know yet?
Well, in our case, we have most of the projects have, well, maybe half of them have a finished product at the end. Some application, it being again a software department, some application that's actually working and can be given over. Now those generally have to be tuned to be the professional, fully releasable product. But we do have some that are prototypes just to show proof of concept.
Yep. And we had a high proportion of respondees in this session who said they're in mechanical, aeronautical, computer, electrical. So it's likely that a lot of folks are heading into this expecting that they're going to do a physical prototype. So I'm going to give it another second. I'm going to close the poll out.
Yeah, I just might follow up on what Dean was saying and what you're talking about is as far as testing potentially partial prototypes. My colleague Matt Swenson, he was in the earlier session, I think he's probably in this session, but had come up with a tool that we use with our students, design validation matrix that's fitted to the specs, but breaking that down into all sorts of little tests, from creating first CAD drawings to simple proof of concept experiments, unpacking the specs into lots of little steps. In some cases, last spring, I think we had a couple of teams that shifted some of the focus of their project to making test fixtures to validate different aspects of the design. And so I guess we need to get out of thinking that it's just all or nothing. There is some intermediate territory, and there's lots of good testing that students can do along the way.
Thank you, Steve. So now we're going to move on to some of the live questions from the audience. Laura, have you picked out a few questions for us?
Yeah, so there is one question for Dean, and I imagine everyone else can comment too, but how do you get students to choose tasks that are an appropriate duration? I love the idea of delivering something completely rather than everything incompletely.
Yeah, given that we have a one semester project, in the fall, I work with all the different industries, and I directly, personally sit down with them and we choose a product or a project. And then we try to come up with a core that they say, if they get this, they'll be satisfied, but here's a bunch of optional features that we like and we know we may or may not get. And so virtually all of the projects that are offered to the students have that kind of a format to them. And then we just offer the 22 projects to the 90 students. And then the students get to say, what's my first, second, or third choice? They don't get to bid as a team. And so we assign students based on their interest in the projects. And the projects are so different. We run over 90% every year that get one of the first 3 out of 20, which is pretty good distribution.
Chris, want to add something about final deliverables?
For us, what it looks like is revisiting the course requirements and the rubrics with the students and with what they do deliver. So all the competencies will remain the same, but the form of the delivery may need to be modified. For example, if it's impossible to deliver an implemented solution, particularly in hospitals where the timeline is just out of their control, then instead of an implemented solution, we do allow implementable solution or full solution proposals. But here's the key, is that we don't want students thinking at the beginning of Capstone that, well, it's okay if it doesn't happen. So we lean everything in the direction of a deliverable. And so if there's, overambitious promises, adjustments will be made, but we'll do that on a case-by-case basis. We'll also try to make things modular, kind of like the sprints, so that teams can reach certain milestones if it becomes absolutely impossible, whether it's their fault or whether it's just circumstances or they were overambitious. We get them to deliver something, whether it's just a handoff, delivering training programs, preparing modified versions, slant everything toward the client's definition of success. But we start the course and we start Capstone with everything leaning toward you deliver something. And then we go modular if we have to on a case-by-case basis.
So I believe Laura has a few more questions for us.
Yeah, so another question, this is for everybody. How do you scope projects to be completed virtually? Are there any easy to learn computational or modeling tools that could help when scoping projects? Especially relevant for multidisciplinary teams that might have various backgrounds?
Yeah, I guess I might just offer one partial answer, and a lot of you may have done this last spring, but our IT staff was very helpful in, well, we have a lot of software that students can access on virtual lab environment and with student copies. But even some of the larger tools that were on our machines on campus, we made available virtual machines where students could log in from home, and essentially, since the machines were not being used in the lab, they could be used by students at a distance. And I was pleasantly surprised at how well that worked.
Also, in industrial engineering, when they're making prototypes, it's not unusual for them to create a dashboard that can just be ported from platform to platform for a particular solution. And in fact, that's a form of a tangible deliverable for them. And so, learning Tableau and VBA, creating dashboards is a really great way to make a deliverable that's immediately usable.
I think in our area, in computer science, we have most of the projects can be set up so you can have shared servers, they can work remotely pretty easily. In the cases where we have hardware involved, it's typically been like for an augmented reality project last year, we had to be able to use low energy Bluetooth to communicate to some devices and things like that. In those cases, the students just took the hardware home with them and worked with it in their homes.
Steve, there is a follow-up here. What kinds of machines do you make remotely accessible?
I was talking mostly about software before, but I would say our 3D printers and to some extent our laser cutter was maybe almost as busy when students were off campus versus on campus. There was facilitation by having, since some of our grad students could still have on-campus access, things could be bundled up and sent in. So that, remember that there are maybe people that can help remediate some of the production process. Let's see, I think
And also, your IT
ahead.
folks can help you with access for special purpose software like our simulation software, our facilities planning software, and they have made it possible and even more possible now for students to go in through VLAN and get in there and use those pieces of software that they don't have necessarily on their computer at the professional level.
Awesome.
And one thing to keep in mind, I mean, with in mechanical engineering, manufacturing something, it always has like a big obstacle that needs to be overcome. And certainly things were constricted when students couldn't gain the firsthand experience of actually building the parts they designed, which is a tremendous learning experience. But we did expand greatly, and I think want to continue in that direction about doing much more rigorous engineering release reviews based on the student design documents and bill of materials and drawing packages. And so I would, that may be an example of taking lemons and converting them to lemonade through a much more rigorous engineering release process.
So our next question we're actually going to pose to everyone here. So we're going to do another poll. We had a question about how much money is given per student or team in Capstone courses. And so Beth is going to launch a poll so we can see what other schools are doing.
Coming in, we'll give you another couple of seconds to wrap up. All right. So it looks like most responses came into the $1,000 to $5,000 range. With a nice variety.
Yeah, thank you. So another question for panelists, and of course you can jump in the chat too if other people have more input. But this was one of the questions that was pre-submitted. What are some of the best ways to have Capstone teams meet virtually and make sure that each member is participating to the fullest?
Well, I'll start. For one, you can't make sure, and we'll learn about that in teams, but you can only do your best to create that culture. But listing the tools for them that they can use to connect. Also, my co-coordinator and I polled our students as to what tools they use to connect, whether it's file sharing, whether it's video meetings, and in other ways of keeping in contact, like through Slack. We've actually polled them and then gave that information back to them. And when we did it in our discussion board, not only did they leave us links, but they gave us explanations as to why this was a particularly good method. So that's one of the ways that we do it, is we provide them some information and we also gather it.
This, one of the things that we did, and I assume this is a general service that you can do with Zoom on campus, but we created a special Zoom number for each team. And if the lead instructor does that, then you actually get notifications when students are spontaneously, they don't need to wait for you to show up. I mean, as long as you enable the meeting the right way. But I was pleasantly surprised at the number of times that students, teams spontaneously use that. And sometimes, you know, they might just say, can you drop in and answer a question? So I think there are a couple tools like that that maybe we didn't use as extensively before, but I think would continue to use extensively, you know, even if our conditions go back to some form of normal.
In our case, the students are very used to doing this even before this. They have their weekly meetings with their sponsor, and that's always a Zoom or a Skype or something like that. Now, the way we handle how do we know that they're contributing and what are they doing? We do that a couple of different ways. One is we have a survey, or we poll the students themselves, like about every 6 weeks. So maybe 3 times during the semester. And each person on the team, so a team of 4, so each person gets 100 points. And on those 100 points, they say what percentage of the work was done by each person on the team, including themselves. And so they distribute that 100 points across. That's always, we keep that completely, we're very protective of that data. We don't ever let people on a team know what other people, how they rated them or anything like that. But we can watch to see if there's somebody that's just not carrying their own weight. And then we kind of use that information where we have regular, like at least once a month, we have half-hour meetings. And in the case when after pandemic, these were virtual meetings where we would meet with the team members, and then anybody that's we think isn't performing, we can drill down and say, what have you been doing? Where is your code being checked in? They have to produce weekly reports where they say, this is what we accomplished last week, this is what we're going to do next week. So we can go back and look at those and see, are these people doing what they were expected to do?
So one more question. This one was pre-submitted as well, but also relates to one of the live questions. So basically, how do you manage student, sponsor, and faculty expectations? Specifically, one of the live questions was about how at the beginning of a project, students often think that they know how to proceed, but then they discover more uncertainties that they're not sure how to address, and they might want to scale back. But they need to make sure they're persuading the client that it's okay to delay difficult features until later. So how would you manage balancing what the students are doing and their expectations with what you might be doing as a faculty member or a project advisor or mentor?
That's a lot of nested questions, but I will start. I don't think I'll answer all of it, but I don't know if any of you have ever seen the business hype cycle, where it starts with peak of inflated expectations, and then it goes into trough of disillusionment, and then slope of enlightenment, and finally plateau of productivity. So in the past, I've presented this to the students and say, this will happen. It happens in almost everything from getting a holiday gift to being part of a business. And so they'll go through the hype cycle. And I think that preparing them helps. They still get quite ambitious. And like I said, the mindset makes a big difference. We've also done some work in preparing the initial interactions with clients and students and having them get together and scope, how are we going to handle this if it gets a little bit off course? So we have that happen right up front. So I don't know if it's answering all of that question, but preparing the students' mindset, also preparing them to talk about it, fly the plane a little on the ground, a little bit in the simulator before it happens with the client.
I made some comments before about just some of the pre-discussions that you have with potential clients. And so I think it's generally good principle, given the constraints that you could see, to present the stretch project to the students as the project they need to work on. But at the same time, you're having a discussion with your client about putting together a scoping document. It's probably also good in the back of your mind to think about what is maybe a likely adjustment if one is needed. And that's definitely helped. I think what also helps is to, Dean talked about the Agile method, and a lot of people here use sort of a phase gate approach throughout the course with design, snapshots, and reviews on a periodic basis. And those are highly effective. Maybe just pursuing that a little bit further, probably half of our teams, when they have their weekly team meetings, a lot of times will have their client on the Zoom meeting with them. And maybe not surprisingly, but those are the teams that have less problems with mission creep and getting over their heads.
I think I just add one thing. The one thing you never want is a surprise. Instructors don't want to find out at the very end that you'd been telling them everything was great, but it wasn't. Same with the mentors. And I'll just kind of half-heartedly say there's 3 major ways to solve that. Number 1 is communication. Number 2 is communication. Number 3 is communication. You need to be talking to your mentors, to your faculty, advisors, whatever.
And I guess I might just make one other comment. I think largely here in the Capstone community, we talk about most of our projects being externally sponsored. I mean, we do have some internally sponsored projects, and ones that require special oversight are competition type projects where you don't have that balancing force of the outside client. So I guess I would encourage people that are thinking about capstone projects related to competition projects to proceed with caution.
So we have one more question here from the audience. We are thinking of merging 2-semester capstone into 1 semester for spring 2021. Any thoughts? It's from EC, computer science, and systems, to the panelists.
Did you say going from 2 semesters to 1?
Merging 2-semester capstone into 1 semester.
That's going to be challenging, but it's going to be doable. I think one of the best things to do is really work on front loading the process part of it as much as possible and getting them their projects right away. And also think that, we're role models, so modeling it for the students, right, by saying, this is what we do. We have a situation in front of us, and let's go for it. Let's attack it, and let's make it work. So I think that mindset still has a lot to do with this. Also, like Steve had mentioned, is what are some of the modular deliverables that we can provide if we can't get as far as we wanted, but we don't want to start that way. What can we do? What is possible at this point in time? And have the students think about that in terms of milestones.
Awesome. I will also follow up on that. Like, we have 3 quarters, and instead of merging it into 1 quarter at the time, the build time will be switched around in a way that they can be as much as possible in person there. So if you can switch some timelines around, that might be maybe better than just compressing it in 1 potentially. Laura, do we have any interesting?
Can I add something on it? Because
Sure,
we run a 1 semester project. And
But
it's a very doable thing. It works really well. And I've had people say, well, why don't you do a 2-semester? And in dealing with these 20, 22 different companies every year, when we try to pick out the best projects for them, we're talking to them in October, November, whatever. They come up with a project. It's going to start in January. They're going to have it at the beginning of May. They still think that's a long time to wait. So if you're trying to line up a project, if you're not wanting to work over the summer, you're probably lining up your projects in May or the beginning of June to not be delivered until next May. And I know the people I work with, the projects they get excited about are the ones that they're going to use right away. We've had multiple cases where they put them into service as soon as they get them, where they take the results and they fly down to NASA and demo the end results. You know, they want it right away and they don't want to wait a year. In the software world, waiting a year for something is a long time.
awesome, Dean, thank you. So we are switching over to some questions back to the audience. And one of the questions I have is if during the semester going from the in-person mode to we have to go completely online mode, how are some of the audience members thinking about handling that instant switch over to, or what we call it as high flex mode? How are some of the audiences planning on doing that? And if you can add to chat, that will be great. So we can actually see your comments coming in and we can read out some of the interesting ones. While folks are adding that, there is also another question from the audience about, due to uncertainty, has anybody considered having students do a business continuity plan at the beginning of their projects? So this is a question to the panel members.
Can you say the last part of that question again, Shraddha?
Has anyone considered having students do business continuity plan at the beginning of their projects?
Business continuity plan?
Mm-hmm.
Okay. Can you define that for us?
I would need to see the person who asked the question. Rachel, can you unmute?
Yes, so a business continuity plan typically is what, it's kind of like a disaster response plan. So in case something goes bad, what will be our response? So at Seattle University, as soon as COVID-19 became something we were aware of, we immediately had all of our teams do a business continuity plan with worst case scenario, not being able to work on campus, which actually happened very quickly. And so I'm thinking we may actually have students do it this year just because we don't know what the academic year is going to look like.
Okay, yes, we did do a form of that when we went off campus. We didn't call it that, we're in industrial engineering, and we had each of the teams state where they were at that point in time, what they were prepared to deliver, what they thought might be compromised, what they were going to do about it. So we did a form of that. And that was helpful because they saw that all was not lost and they actually rebounded quite nicely. I think probably having a format for that would be better because credit to my co-coordinator, Hugh, who was the primary coordinator, Hugh McManus, for getting that off the ground and getting some of those questions together so that the students could be thinking about that and not just, oh, what do we do, but to be pretty systematic about it. And that was helpful.
We do a formal risk analysis that is, they do it and then they update it every sprint. And on the risk analysis, they say, here is the list of risks that we have. What is the likelihood that it's going to happen? And then they'll have a contingency plan. So they'll say, if I'm not getting my sample data from the customer by a certain date, here's what's going to happen. And then that trigger date, if that trigger date comes, then they have a action that they're going to take. So it's all upfront and planned out.
Rachel, there is a lot of audience members who are saying they're doing some form of continuity plan, which I think is super awesome. And I also saw a comment in here saying that we are Conrad mentioned that I'm having students teams put together 2 schedules, assuming in-person mode and remote mode, and I think that's really awesome too. Laura, do we have any additional questions or comments or questions back to the audience?
Not that I can see.
Okay.
Can I go back to one that I don't have an answer to, but it was related to collecting money for projects.
Absolutely,
And
Dean.
I'm kind of, I'll let Steve and Chris answer this one for me, but, or if anybody else wants to. I have talked to people who say they charge quite a lot for their projects. And, you know, it's like $15,000 to $20,000 per project. And one university told me they actually bring in $750,000 a year to the university through those, through that funding. But what happened then is the administration saw those numbers and kind of cut back on other things that they were giving because they saw, oh, engineering is getting all that money where humanities can't do that. And so it was a double-edged sword. You know, it was like they were having to give up something because of getting it. So I'm just wondering if people have any trouble with that.
Thank you, Dean. Dean, I had a question for you. You mentioned about international projects that doesn't need travel. Could you help us understand that real quick?
Yeah, a really quick one. So a lot of students would like to gain some experience in working internationally, but they can't take a semester to go someplace. If they do go, they end up with a toy project. It's not real. So there's all kinds of issues with that. A lot of the projects that we're talking about here, the companies, the sponsors aren't in town. The students aren't going to the company regularly or anything, even ever often. And so it was actually at a Capstone conference in Boulder where I was sitting across the table at supper one time, and Karsten Kleiner from Germany was there, and we were talking about, he did capstone projects in computer science. I did them. I said, well, we do projects for companies 300, 400 miles from us. The students don't travel. We could do one for a company in Germany, but I don't know any companies in Germany. Can you talk to one of your sponsors and see if they would take on one of our teams? And then this would work just like a multinational company where the development team is in the US, but the team lead is in Germany. And he said, oh, I like that idea. Tell you what, I'll do that if you find a company here for me. So we just did that. We traded companies. We've been doing projects now for 8 years with that company in Germany, and it's been fantastic. We then started adding, we did exchanges with Germany. We're doing them with Australia. Other people started saying, this is interesting. We'd like to do this. So I'd pair up people in other countries, people in other disciplines saying, well, I'm in mechanical engineering or I'm in electrical. Can you pair me? We even have a journalism one that we've paired up. So now we have an International Capstone Exchange website where anybody that's interested in this can go to the website, log in, and say, pair me with somebody.
Dean, I just posted the link in the chat as well.
Okay. So we have probably 20 to 25 universities involved in this right now.
Thank you, Dean. We have about 5 minutes remaining. So any closing thoughts or comments from the panelists?
I was just going to talk about docking the ship. You know, when it comes to the end, it's actually not a cliff that the students go encounter. And so we do talk about, particularly in industrial engineering, but in other majors as well, if you're not having a prototype deliverable, amazing handoffs are really valuable. Comprehensive written turnovers are amazing, and video guidance and training programs, strong documentation for code or procedures, and then clear springboards for multi-phase projects. So these are just some things of scoping a project when something unforeseen happens and you can't quite get to that point, but you still want to deliver. So this form of project scoping is also further reinforcement for communication and documentation aspects of Capstone.
Awesome,
No,
Chris. Thank you.
wholeheartedly endorse that, Chris. And I mean, a lot of us have special forums that we do at the end of the year to celebrate our achievements in Capstone. And I mean, there's several things noted in the previous session about people continuing on, but in a virtual way with ways that they've captured stories or have archives of previous projects. And so there's a whole host of students that have been through what maybe students in the fall might experience, and taking time to actually look over what students have done is a great way of reinforcing our model for best practices in the course, and for what the whole design process really looks like.
I guess one final thought, we have each of the teams make a little 3 to 5 minute video that describes their project and what they did, and they show demos of it. We post those out on our website. Those are a really good recruiting tool. So when students come in for the first visit to the campus and they're interested in being a computer science major, we can say, well, just go out here and look, this is the kind of stuff you're going to be doing when you're a senior. Or when companies come in and we're talking about maybe being a sponsor, we can say, well, here's the kind of thing we've done before. So it's a very good tool in many ways. And the students can also tell their grandma, hey, go look here, see what I did.
That's
And
also
they
a
like
good
that.
inspiration for students coming into Capstone to see what can be accomplished.
Yes.
And then just as a tip, I always identify the best work and share it as being average.
Okay, thank you all. We have about 2 minutes remaining. I want to thank the participants for attending and being here. I don't want to try to push this session extra minutes, so I would rather wrap up early. There are some interesting questions and conversations still coming along, and we can continue posting and discuss sessions on our live notes as we go forward. And about today, one of the nifty flops that I had was I tried the slides format instead of Google Docs, and I don't think it worked. So don't do that again. But the other 2 sessions used Google Docs, and I think that was working great. So this was something I was struggling with. Should I fail fast and pivot? But I decided to go with it, and I should have probably switched over. So anyway, that's a closing remark from me. Once again, thank you all for attending, and please continue our discussions. We will be updating our Scribe notes and the Google Live notes and continuing this discussion on Slack channels. So please be a part of it. Beth, if you could pop in the link for the next session, or at least the time, that would be very helpful.
I did, and then everybody's thanking you, which is really nice, but it's also on the last page of the slide deck that's here. So if you're in the live document to post comments, the very last slide has the link to the next section.
That's awesome. Thank you again.
Thank you.
Happy summer.